Welcome to another podcast. In this episode, we're going to be taking a look at how to use the TI-Nspire calculator app to look at normal distributions and some of the problems associated with normal distributions. So I've constructed a problem for you here, and I've opened up a calculator file. If you need a calculator file to follow along with, remember you can simply open up any file and just simply hit Add Calculator to add a page to the document. Here we're going to look at assistant professor salaries. We're assuming that we're looking at a normally distributed set with a mean of 67,000 and a standard deviation of 8,000 in terms of the salaries. And I want to ask the question to start out with: what percentage of assistant professors make between 60,000 and 80,000? Now, the questions which ask us to find percentages are found using something called the normal CDF command. The normal CDF command, like many of the distribution commands, can be found under the... you have a choice here of either probability or statistics. For example, I could go statistics distributions, or I could go probability distributions. Either way takes you to the same menu. So I'm just going to stick inside that menu, but probability distributions. And the normal CDF command is the command that will calculate averages between values. So it gives me a choice of a lower bound and an upper bound, and that is the bounds on the interval that I'm looking at. So if I'm looking for the percentage between 60,000 and 80,000, then the lower bound would be 60,000. The upper bound will be 80,000. Mu stands for the mean of my distribution. The mean here is 67,000. And sigma is the standard deviation. The standard deviation in this case was 8,000. You can see these kind of behind it grayed out, but you can see the mean and standard deviation as well as problem number 1. So once I get all that information entered, I hit OK. This gives me the command that the calculator uses to determine the percentage, and here the percentage of assistant professors that make between 60,000 and 80,000 is 75.7%. So it automatically gives me the probability, but we probably will want to convert this to a percentage by moving the decimal 2 places to the right and affixing a percent sign. So 75.7% would be the appropriate percentage here. All right, the second question that's asked is: what percentage of assistant professors make more than 70,000? Now, to answer this question, since it's a percentage that I'm looking for once again, I'm still going to use normal CDF. However, I want to know those that make more than 70,000. So more than 70,000 is 70,000 for the lower limit, and then there is no upper bound. I mean, technically the upper bound is infinity, although there's probably a practical upper bound of, 200,000, 300,000. You're likely to ever see an assistant professor make that, but that's a sort of a theoretical upper bound. But technically infinity is the upper bound. So we can't put infinity into the calculator in this sense. And so what we're going to do instead is pick a really large number. And so what I've been doing with you in class is just choosing 9e99 as a way of replicating 9 times 10 to the 99th power. In other words, an incredibly large number. It's effectively infinity. So this is a interval above 70,000. My mean and standard deviation have not changed. The mean is 67,000 and the standard deviation is 8,000. So above 70,000 is 35%. So 35% of assistant professors, 35.4%, make above $70,000 a year. All right. The next question which is being asked, so question number 3 here says, what percentage of assistant professors make less than 50,000? Once again, I'm asking for a percentage. So if I'm asking for a percentage, then I should calculate the normal CDF. And this time it's below 50,000, so I need a negative 9E99. That's the default lower bound, as you can see, so I'm not going to mess with that. That basically the default lower bound there is negative infinity. So the upper bound would be 50,000 because I want below 50,000. The mean of 67,000, and the standard deviation here is 8,000. So roughly 1.7% of assistant professors will make below 50,000, usually first-year professors. Okay? If we then go to question number 4, notice things change a little bit here. Question number 4 says, how large must an assistant professor's salary be to rank among the top 10% of salaries? So here I'm looking for a salary. That's a data point. I'm looking for a data point here, a data point that corresponds to the top 10%. But remember, you don't find data points, you find percentiles corresponding to data points. And so if it's going to be in the top 10% of salaries, then that corresponds to the 90th percentile because 90% of the salaries are less than this salary we're trying to find. So the way to do that is with a command in the very same menu underneath normal CDF called inverse normal. Now what the inverse normal command wants is the area beneath your intended target, meaning it wants the percentile. So if we want a data point that is going to be the dividing line between the top 10% and the bottom 90%, then the area that it wants me to give is the area below that point. In other words, it wants me to get the percentile. Now it's the 90th percentile, but remember the area under the curve is equal to 1. So 90% of that area is 0.9, or the area below the point that I'm looking for is 0.9, corresponding to the 90th percentile. The mean of the data set is 67,000, and the standard deviation is 8,000. So once you have those three things entered, the percentile, the mean, and the standard deviation, you can hit OK. And then this tells me that a salary here of $77,252.40 corresponds to being in the top 10%. That's sort of the cutoff for getting into the top 10% among salaries. Okay, last question I want to take a look at with you here. It says, what assistant professor salary corresponds to the 25th percentile? Here I actually call out the phrase percentile, and if I do that, then the 25th percentile is the data point that has 25% below it. We talked about in class that this is called Q1, or the first quartile. So I want to find the first quartile here, and since I'm looking for a salary, I'm looking for a data point, I should be using inverse normal. And the percentile is the 25th percentile, so that means there's 25% of the area under the curve beneath the point I'm looking for. Once again, my mean and standard deviation have not changed. And so there is the salary I'm looking for. The first quartile are all salaries up to $61,604.10. So if you make a salary below that, you're in the bottom 25%. Make a salary above that, you're in the top 75%. So it just depends on your point of view. These are the two commands that are sort of indispensable when working with normal distributions. You have to do these commands in your calculator if you want to get accurate results. We could use the empirical rule to estimate these, but we won't be able to get exact answers unless we resort to using the calculator or looking them up in a table, but we've decided that we're going to use the calculator to give us the ability to calculate these types of problems. So just remember, if you're looking for a percentage, not a percentile, a percentage, then you're using the normal CDF command. If you're looking for a data point and you're given the percentile, you're given the percentage, then looking for the data point involves the inverse normal command. That's the way to kind of keep these two things straight. So these are the 5 possible cases of problems that you might run into. Hopefully this made a little bit more sense and you can better learn how to use the calculator to handle these types of problems. All right, thank you for watching.